Hey everyone, it's Mrs. Brimlow, and today we're going to look at some more substitution method problems, but that have some different steps to them. So, a copy of the notes have been linked to Canvas, or you can watch the video and get a copy when you return. Okay, so we're actually going to start with the warm ups today. So, solve for y. Well, if my goal is to get y by itself, I have to get rid of everything else with it, which means the 2x. So since this is a positive 2x, I would subtract it from both sides. So that leaves me with y equals. Now 5 and negative 2x are not like terms. I can't combine them together. So I just write them as an expression together, keeping their signs. Okay. So same thing here. My goal is to get x by itself, meaning I need to move this negative 4y. So I'm going to add it to both sides. So x equals, once again, can't combine the terms. So I just write them as an expression, okay? So we're going to need to use that concept today of solving for x or y before we can finish solving systems. So the first step to solve a system of equations by substitution is to make sure that an equation is solved for x or y. If there is not an equation, you will need to create one. So equations can be written in a lot of forms. This form right here is called standard form, and then we rewrote it to slope-intercept form just by using our properties of solving equations. Same thing here. This is standard form, and we just rewrote it in a different form. These are the same equations. I could go from here back to here, just doing the opposite step, so they are equivalent. So look at both of your equations and see if there is one where a variable is already by itself. It doesn't have any coefficients if possible. So we have negative 3x plus y equals 8, and then 8x minus 3y equals negative 19. Well, both x and y have coefficients in this second one, and they're not going to be easy to clear. However, in this first one, we have y by itself. All we have to do is move that negative 3x. So I'm going to bring this down underneath these equations, okay? So I'm going to add 3x to both sides. So y equals 3x plus 8. Once again, we can't combine 3x and 8, so we leave it as is. And now I can solve this system because I know the value of one of my variables. So I'm going to replace this 3x plus 8 with the variable y in my second equation. That way I have all the same variable and we can solve. So this says 8x minus 3 times 3x plus 8 is equal to negative 19. So this point, I can see I have the same variable I'm working with. I can solve for this. So you're just going to want to make sure that you follow the steps to solve an equation. So distributive property first. So I'm just going to bring down the 8x. Negative 3 times 3x is negative 9x. Negative 3 times 8 is negative 24. Combining like terms, I get negative 1x minus 24 equals negative 19. And now I'm down to a two-step. So I'm going to start by adding 24 to both sides, which is 5. And then I got to divide by negative 1 because I want positive x. So x equals negative 5. Okay. So now I need to solve for y. So which equation do I use? Well, any of these three equations are going to work. These two equations right here are the same equation. They're just written in two different forms, and we can write all equations in multiple forms. Or I can use this equation. So we want to use the one that's going to be the least amount of steps or makes the most sense. So in my eyes, it's going to be the y equals 3x plus 8. It's literally saying y is equal to this expression. So I'm going to come over here. Y equals 3 times x, so 3 times negative 5 plus 8. So y equals negative 15 plus 8, which is negative 7. So our ordered pair, or final solution, would be negative 5, negative 7. That's where these two equations would intersect on the coordinate plane. Okay. So when we don't have an equation where a variable is by itself, we create one. So that has to be our first step. So it ends up being 3 steps. So we started here, getting a variable by itself. We moved into substitution, and then we solve for our last variable. Okay. I'm going to do one more. Okay. I'm going to do number 3. So I have 2x plus 4y equals negative 2. And I've got 4x minus y equals 6. So 2x plus 4y, they both have coefficients. And 5x minus 1, well, the y is just a coefficient of 1, so I can eventually get that by itself pretty easily. So that's the equation we want to work with. So I'm just going to rewrite it underneath. Okay. So once again, my goal is to get y by itself. So I'm going to start by getting rid of x. Make sure you carry your signs all the way through. That has a negative sign in front of it. So this is negative 5x plus 6, since I can't combine them together. Now we have to be careful here. We're not done. I want just y. I don't want negative y. So I divide everything by negative 1 to get y equals 5x minus 6. Okay, so that's the equation I'm going to use to solve for y and x. So once again, I'm going to substitute this in for y to my other equation. So this is going to look like 2x plus 4. And then I'm going to replace the y with the whole expression, 5x minus 6 equals to negative 2. I'm only solving for one variable right now, and I can finish doing that. So with this one, you just had to be careful that yes, y is by itself, or it can easily get it by itself, but it has that negative sign, so we need to make sure we make that positive before we start. So start with distributive property. So I get 20x minus 24 plus the 2x equals negative 2. Combining like terms tells me I have 22x minus 24 equals to negative 2. Add 24 to both sides. 22x equals 22. Divide by 22, x equals 1. All right, so now we need y. Once again, I can plug it into this equation or this one because they're the same. So I'm going to use the one that we rewrote because it's going to give me y right away. So y equals 5 times x, which is 5 times 1 minus 6. So y equals 5 minus 6, which is negative 1. So as an ordered pair, these two lines would cross at 1, negative 1. That would be their solution. Okay? So you can finish these notes, and then there is a practice sheet for you to try in Canvas. If you have any questions, let me know, and I will chat with you soon.